Okay, so here I have just taken one of the questions from the practice problems that I put on Blackboard last Thursday for the quiz. The problem says, if 25 grams of iron 3 phosphate reacts with excess sodium sulfate in a double replacement, how many grams of iron 3 sulfate can be made? The first step to any stoichiometry problem is to write balanced chemical formulas for each of your compounds using subscripts, and then you're going to balance your whole equation using coefficients. So if we take out what compounds that we have in this problem, we have iron 3 phosphate, sodium sulfate, and it tells us it's a double replacement reaction. We will find out our products by analyzing what a double replacement reaction is. In a double replacement, you're going to have two ionic compounds reacting, which is a metal and a nonmetal, or in this case, a polyatomic ion, and another metal and a nonmetal or a polyatomic ion, in which the metals are going to switch places with each other in the products. So first I'm going to write out iron 3 phosphate's chemical formula. And if you look at your periodic table and find iron, you will see that it's Fe. And this 3 right here is not going to go in my chemical formula. It is just going to tell me the charge of iron. Since iron is a transition metal, its charge can vary, so I will always specify, and the problem should specify in parentheses and Roman numerals of what the charge is on iron. And then phosphate, anything that ends in ATE or ITE, usually you're going to know it's going to be a polyatomic ion, because if it was not a polyatomic ion, if it was just phosphorus that he was talking about, it would end in IDE. So once you see ATE at the end, you're going to know it's a polyatomic ion, and you're going to go to your polyatomic ions list if you don't already have it memorized, which I'm sure nobody in the class does, but common ones like phosphate, sulfate, nitrate, chlorate, and carbonate should be become common to you as we keep going through the semester. But anyways, if you don't already know it, just look down here and you'll see it says phosphate is PO4 and it has a -3 charge. So we're going to write PO4. And I always just write the charges above each element or compound that I have, just so that I know when I go back to balance the chemical formula exactly what the charges are, and I don't have to remember them. And then it says the iron 3 phosphate reacts with excess sodium sulfate. So sodium sulfate is going to be my next reactant. So I'm going to put a plus sign. And then sodium is Na. And the charge on sodium is +1. Now, if you think back to when we talked about balancing charges, all of the group 1 elements are going to have a +1 charge. Group 2 is going to have a +2 charge. Group 3 is going to have a +3 charge because remember we skipped the transition metals. So group 3 is over here, has a +3 charge. Then we kind of skip over group 4 because they can act a little weird too. So we skip over to group 5 and then we hit our -3, -2, -1. And our noble gases right here don't carry a charge because they have a full octet of valence electrons. So it's kind of easy to just remember the charges as -1, -2, -3, +3, +2, +1. So anytime you get kind of confused, just remember the group number and you'll hopefully can go from left to right. So sodium has a +1 charge. And sulfate right here is going to be the anion with a negative charge. And if you go to our polyatomic ions list, sulfate is right here, SO4 with a -2 charge. So Na and then SO4 with a -2 charge. So there's our reactants. We have iron 3 phosphate and reacting with sodium sulfate. Then I'm going to put my yield sign or the arrow, and I'm going to write my products. Now, like I said, it's a double replacement. So if we look here, in purple I have iron and in green I have sodium. These two are metals. They're the cations with a positive charge. And they, remember, are going to switch places. So sodium will now pair with phosphate in the products, and iron will now pair with sulfate in the products. So I'm going to write my sodium phosphate next. So sodium still with a +1 charge, phosphate still with a -3 charge, and then my other product is going to be iron sulfate. So plus iron still with a +3 charge, and sulfate still with a -2 charge. And then I have my skeleton of my chemical equation. Okay, so if we look up now to balance our formulas. Now we've written the formulas, but in order to balance formulas, we must balance the charges on each element or compound in the formula. So we're going to go to sodium sulfate first in order to kind of show you how this works. Sodium has a +1 charge. Okay, sulfate, SO4, has a -2 charge. So if we look at what this looks like, we have sodium represented as this green circle with a +1 charge. Sulfate, which is S and then O4, one little molecule, has a -2 charge. The whole sodium sulfate needs to equal out to have a charge of 0. Now right now it has a charge of -1, because if you take +1 plus -2, the overall charge is -1. We have to fix that by adding more of one or both substances in the compound to make that charge equal to 0. So what we can do to get another positive charge is we can add another sodium. Okay, so now we have 2 sodium and 1 sulfate, and we have +2 over here, -2 over here. That's a net charge of 0. Because if you look here, this now is a +2 with 2 sodium, -2 with 1 sulfate. So since we do have a net charge of 0 now, we can write our balanced chemical formula by putting a subscript of 2 next to the sodium, because we have 2 of them to balance out 1 sulfate. Okay, now let's try over here the iron 3 sulfate then. This one's a little bit trickier. So if we start with the total overall charge right now before we balance, we would have a +3 on iron and -2 on sulfate, giving the overall net charge of +1. Again, we want to have a net charge of 0, so we need to make that more negative. So right here, I have an iron represented in purple, 1 iron with a +3 charge, and right here I have 1 sulfate with a -2 charge. If I add 1 more sulfate, I now have 2 sulfate, 1 iron, so a -4 charge over here, +3 right here. I'm at -1, so that sent me the opposite direction. So I need to continue to kind of add either element or compound until I get a balance of 0. So if I add 1 more iron, oops, I didn't show the charge on that. But these would both have a +3 charge, so I'd have a +6 and a -4. So now I have a +2 charge. If I add 1 more sulfate, I have -6 charge over here, +6 charge over here. So a net balance of 0. positive 6, negative 6. 2 iron, 3 sulfate. So a total of 2 iron, 3 sulfate. Written as subscripts, I would have iron with a little 2 next to it. And then remember, if we have more than one of any polyatomic ion, we have to put parentheses around it. So we'd put parentheses, SO4, close your parentheses, and then a 3 subscript. Again, 2 iron and 3 sulfate. You can also remember this as our drop and swap rule. So the charges, if they're written above them, kind of like I did right here, if you drop them and then swap them, you'll notice that you have iron with a 2 and sulfate with the 3 next to it. So that's kind of a quick and easy way to do it, if that's how you want to remember it. Okay, so now that I've balanced all of my formulas, then I would go back and check that I have a net charge of 0 on each of them. And I do. And so then I would start to balance my chemical equation with coefficients.